Hello, everybody. Good evening, good afternoon, and good morning, potentially. Thank you for joining this Neo4j Live. Today, Rethinking Data, a data scientist's first dive into GQLs. I think this was, if you think, oh, this title sounds familiar to me, then you're not wrong. We had Suha join us at Notes in November last year, but unfortunately, technical issues prevented her session to be fully, audible and understandable what you were saying. So we said this cannot be, and then we cannot leave this as is. So we are taking this chance and doing a repeat, more or less, but a little update maybe, but a rerun probably is the better word for it, to give you all the chance to actually understand what Suha is telling and is talking about, and how we can remedy that technical issue back in the day. But nothing else has changed. As usual, this session is live. So if you have any questions, any feedback, we'd like to hear it. We'd like to see it. Towards the end of the presentation, there will be time for a couple of questions if you have it, and we can do as such as usual. So I'm really happy to have you all join today to hear what Suha will present today. So warm welcome to you, Suha. Thank you for joining.
Well, thank you so much for the introduction, Alexander, and thank you for clarifying about why this might look familiar and why I'm here again. With that, let me go ahead and share my screen.
So while Suha gets her screen ready, I'll quickly. I don't know if you introduce yourself a little bit in the run of the stream, but you are a data scientist at Attention-Arc. Mm-hmm. And you work sort of, it seems like, at the intersection of research and real world impact. So you have this very, very cool PhD in engineering, and focuses on, or you focus there, but still probably do, on cross-spectral face recognition. And I think you showcase a little bit of that today, which is an amazing topic, very, very cool, very, very, I would say, cutting edge technology and very interesting. And throughout this process, you discovered Graph, and you came to the viewpoint of, hey, Graph databases, Neo4j, that could be interesting. Maybe we can combine some of these findings from data scientists, from face recognition, with Graph database aspects or approaching. So yeah, I think that's what we hear today, I think.
Yeah, thank you. Just to preface, I did not know about Neo4j until just a year ago. I met people from Neo4j at a conference in California, and I thought they were such a cool bunch. So then I started working at my current company last September, and I was using a lot of SQL tables.
Okay.
And then I came to realize that there are just, like, once you start working with SQL, as I'm gonna talk about during my talk today, it could quickly turn into a messy spaghetti of tables. So that's when I have started using a graph query language, Cypher from Neo4j. And I'm going to walk through how I used it in my current project. And then I'm going to explain a little bit about how I was able to connect it to face recognition. Because that's a field I worked in for so long.
Yeah, well, that's a cool field, definitely, I think. And maybe, we have some. I'll definitely, I think, have a couple of questions, but I think I'll be quiet for this one mainly. I'll let you have it, and I'll be back.
Yeah, sounds great. And feel free to jump in at any time. You or any of the other audience has any questions.
Yeah, we'll do.
Please interrupt me. Using is allowed.
Yeah.
Okay, let's jump into this. So as you can see, my name is Suha, and the title of my talk today is Rethinking Data, a data scientist's first dive into graph query languages. Okay, so this is kind of an outline of what I'm going to talk about today. First, who am I? And then explain problem at hand a little bit, explain the data sets I'm working with, how I envisioned it the SQL way, and what happened when I switched it to graph database, and how I applied it on a face recognition data set, and then conclude with a few key takeaways that some of you would hopefully find useful in your journey into graphs as well. So, to give you a quick background about myself, I have a PhD in engineering from the University of Georgia, and I graduated in 2023. And my dissertation was focused on cross spectral face recognition using generative AI, specifically thermal to visible. I'm not going to go into super into in depth into details about what this actually entails.
Mm-hmm.
But I provide my LinkedIn at the end. If you're interested in going in there, my scholar is linked in my LinkedIn. Feel free to check that out. Currently, I work as a data scientist at a media agency called Attention Arc in Durham, North Carolina. And as a data scientist at a media agency, we have access to lots and lots of client data. And there are some cool opportunities for a data scientist there, as you can imagine. And the key projects that this were the projects I was working on at the time this I presented it the first time, and I'm still working on bits and pieces of these still. One is attribution estimation for linear TV, which is um, if one of our clients is displaying ads in TV stations, which is linear, um, who gets credit for which website visits, which I think is a really cool application of data science and machine learning. And the next is anomaly detection in ad serving to detect bots, um, which that's a project I have used Cypher and Neo4j for. Moving on, the problem at hand was, are we serving undeclared bots? Because there is robots.txt that most, if not all of you, are aware of, which where bots declare themselves, hey, I'm a bot. And then we stop serving them ads because each impression costs some money. If we are serving bots, that means we are just throwing money down the drain, and who wants to do that? So, how did we approach this problem? It's easy to recognize that humans have routines. We work pretty much the same day every day. I know there are anomalies. I know people sometimes work at night. I know people, our circadian rhythms shifted, but typically humans work from 9 to 5 and sleep from, say, 10 to 6 and play in between and spend time with their families. Bots do not have these routines, and humans also, however randomities, they fall into patterns at the end of the day. That is just the thing. There could be some tail ends to this, there could be some head ends to this, but they follow a routine. So, the first step of this is finding anomalies related to the population. Are the impressions served disproportionate to the population? I'll get into the data sets available in the next slide, but I just want to provide a disclaimer that here I did not use graph databases or the graph query language to solve this problem, but to approach a solution or to just look at the problem in a different way and to find out any um, relationships, anomalies, or anything of that kind, um, just by looking at these graph databases that might not be visible uh, using SQL that easily, using flat tables. And you'll also find me using the names of programming languages like Python and SQL quite a bit because I'm a data scientist. It's just know that it's not a prerequisite to understand any of these to understand what I'm talking about, except maybe one slide where I talk about how to code a little bit. You are very welcome to just zone out or microwave your lunch or dinner wherever you are during that time. But moving on, the data sets I had access to were impressions served in years at a time, but we decided to concentrate it to September and October 2025 just to build something, start building out something, because we cannot just build out with 100 billion rows. And even with September and October 2025 data, we had close to a billion rows, which is a lot of data. But this will be condensed, so no biggie. And this data set had timestamps, zip codes, cities, and states of impressions served, like how many impressions, or an impression is a row in the table, and the each row had information on which city, state, and zip code this impression was served at exactly which time to a microsecond um, detail, I think. And then I also have access to census data, which is just obtained from open source census data available. I do not remember the website, but it was pretty straightforward, and the population here was by zip code. Now, the problem breakdown, um, we serve impressions. We could serve impressions at any time, but we have programmatic trading also works by varying the number of impressions.
Oops. We lost you for a second there.
Is my screen still visible?
Now you're back. Yes.
Okay, cool. By varying impression effectiveness varies by time of day, day of week, etc. People might be looking at more websites during their work hours and maybe looking at TV more during their non work hours. And because this is programmatic, we are more focused on the workday, and commuter population impacts workday and hourly impressions because people might be residing in a zip code, but they might travel to a different zip code to work, so that's a commuter population. Then nighttime impressions are affected by sleep patterns because if most of the population is sleeping, then who are we serving these impressions to? And then there are a few hours where people are not at work nor sleeping, which playing could be playing outside, playing video games, spending time with their family, hopefully. And so some of the assumptions made were 50% of the population, only 50%, 15% of the population is awake from 11 p.m. to 6 a.m. I went into certain census studies and certain sleep pattern studies to come up with this number, which is an average of several things I have gathered. And the another assumption is that we programmed it such that everyone receives an impression during non-work, non-sleep, and sleep hours. So the entire population receives one impression during work hours, during non-work hours, and during sleep hours, the entire awake population receives an impression. So that is 50% of the population in that zip code. And that everyone receives an impression, and then work hours, which are not discussed in this talk, include commuter in and commuter out population. Then the estimated impressions are just simply multiplying one by 30 times or 31 times, depending on days per month, which is September is 30 and October is 31, and multiplied by the population awake at the time. And actual impressions were simply obtained by adding all the impressions together that were served during that time. So anomaly is anywhere where actual impressions served are greater than what we estimated by considering the population and impressions served. This is where I kept creating tables, and at the end it turned into a spaghetti of tables. As you can see here, these are not even all the tables that I had. But to look at just a couple of these tables, here you'll see there are zip code, city, and state, and the timestamp, which month, hour, day of the month, which is on 15th of October at 5 p.m. 25 impressions were served in this zip code, and so on for the other three zip codes as well. And in the bottom table, we have sleep time population and estimated sleep time impressions. Sleep time population is 2548 for this zip code, where this is 15% of the population, which is awake. And we multiplied it by the number of days in the month to get estimated sleep time impressions. You can see why it's so hard to compare tables like these, because they have different columns, they have different types, and it's not easy to join these tables. It's not easy to just simply compare this. I wrote a lot of SQL scripts while working through this, and if any of you have worked with SQL, it's and no CTEs, you know how quickly, how big these could get. There are window functions, of course, we can use them too, but it still gets complicated. So that's when I considered using graph database. To quickly go over what I actually was able to do and how I got myself familiar with Neo4j and Cypher is I went to Graph Academy, and then I just did these two fundamental courses, which is this was 1 hour, and this actually took 1 hour or even less, and this took about a couple hours, and I was able to learn a lot about it in just half a day, give or take. And it was very easy to use. They have everything in here, and you can also look for a solution and then try to understand it if you um, cannot solve it. But these are very easy to understand, and the exercises get progressively harder. So you build the confidence that you are learning something, but at the same time, actually learn something as you move forward. And I used Neo4j desktop after finishing the courses and just got to coding, which felt really easy, especially with my background in SQL and with how easy it was to use these courses. At the end, I also provide a couple other ways you can actually use Cypher if you don't want to download another app to your computer, which is completely understandable. Now, a little bit about graph database. A node is the basic entity in Neo4j, any basic entity in Neo4j, which is this is a node, the data which is actually inside this. We call it a node. A label is a tag assigned to a node that defines its type. So this node's label is impressions, this is time, this is location, and this is period. These are the labels. And a relationship is a directed graph which shows the connection between two nodes. So in this impressions and time, these two nodes are connected by a relationship called occurred at. So number of impressions occurred at this time. The same way, location has these many impressions this time, or location has these many impressions associated with this period. So what is the difference between time and period here? I'll get into that in just a second. Then property, a key value pair stored in a node or a relationship, which is again a node or the relationship, which is this directed arrow. It's a key value pair stored there. Let's go to the next slide to understand that just a little bit better. Node is the actual data inside this, and the labels are time, impressions, location, and period. We already talked about relationship, where this is a directed graph, directed arrow. And the property for location, the properties are zip code. I said it's a key pair value, which is zip code and a value for that zip code. That makes it a key pair value for that property. City and the value of the city, state and the value of the state. The same with impressions. Actual impressions is the key, and the value is a number associated with it. Same for time, months, day and year, and period, type, sleep time, daytime, work time, commute time, etc., and month. Now for data ingestion, I simply converted the data into CSV files and added them into the Neo4j import folder, which is automatically created when you download Neo4j desktop. And I got to coding. As you can see here first, I simply created Okay. I hope you all can still hear me.
Yes, you're back.
Okay. That's just funny. Created constraints just to make sure that I'm not overwriting anything or not duplicating anything, and requiring that the zip code for each of the locations is unique. And the same with month, day, and hour. And for period, it requires a unique month and type. And from there, I simply loaded the CSV with headers. And merge is, if you have used SQL, merge is the equivalent of create or oh sorry, insert. Merge is the equivalent of insert, and here match is the equivalent of select. So as you can see, merge inserts the data and match is simply selecting the data to be added. And this created a beautiful graph. As you can see, there is the location, Newark, and all I did when using that is click on these and see, let me pause this just for a second. In that zip code, non-work time, and that is the period for October, there are 27,766 impressions. And as you can see, it's very easy to spot the anomalies here. Now that I think about it, I should have done something different here, where instead of plotting it this way, I should have plotted Newark, number of impressions during that time, or estimated impressions during that time, and actual impressions during that time, which is very easy to look at than looking at a flat table. Although I did not do it here, but we can also see some other cool things happening here at that zip code. Okay, moving on. As you can see, how quickly we can travel from one zip code to impressions and see how many other zip codes are there where these impressions were served. How many impressions were served at 11 in the month of November. And from there, where does this number come from? This is just, to get there, it takes about at least 20 to 30 lines of SQL. I'm talking about it syntactically, where you go with, as, select, where, and everything. So now with Bakersfield, we again have such just clicking everywhere and deciphering all this information with just clicks. And another thing I want to note here is how easy this is to show and explain it to non-technical stakeholders than walking them through a bunch of flat tables. If anyone is interested in this deeper level of understanding of the data set, which from what I've seen in the industry, sometimes they do. Now, moving on to the interesting part. I did not do any cross-spectral face recognition for this project because I don't really have access to many cross-spectral face recognition data sets anymore that I have worked in my graduate program. But there is an open source data set called CelebA, which has a data set of about 10,000 individuals collected in the wild, which means when I was working and when I was in my grad program, we used to conduct face recognition data collections where we ask individuals to come participate in our data collection, where we take pictures of them, where we take videos of them in controlled environment, where the lighting is set in a certain way that's uniform across all the participants. Here, it's not. That is what is called that is what it's mean by collected in the wild, where even people who are posing for pictures who are posing for mostly media or social media pictures. And these are not controlled. These are not in a controlled environment. And the data set has about 200,000 images, which are not uniquely distributed. It does not mean each individual has 200 images. From what I have seen with the data set, some individuals have only 3 images and some individuals have up to 50 images, which is another thing about these images being in the wild, because controlled data sets usually have almost the same number of images and videos per person. And along with other metadata, which is the images belonging to the same person, all are in the same folder for that individual. There is other metadata available, which is someone wearing eyeglasses, and here are the images with eyeglasses, and someone has bangs, someone has a pointy nose, wavy hair, all these attributes. And all these are available in a CSV file And anyone can download this dataset by just Googling CelebA dataset, and you will be taken to a download link where these images are also suppressed, so it doesn't even take that much storage to work with these. It might take a good bit of memory if you're looking into training a face recognition model, but if you're just trying to play around, this is a really easy dataset to play around with. From this, I did not want to use all 10,000 identities, especially for this demo purposes. So I only used about 100 images, and I made sure that they belong to different individuals. But also at the same time, I have used the CSV file and did the same thing I did with my anomaly detection database. And here is what came out of this. So the central node here is smiling. So these are all the images of people who are smiling. Just to give you a little bit of background information on why do we need these attributes is when you're working with the face recognition data set, there are some things that people do to help recognize faces better, which is categorizing them by male or female. Now, if you say, ideally, if there are 50% men and 50% women in the data set, now if you want to recognize who a woman is, you're automatically eliminating 50% of the data. So now you have 5,000 people to recognize this woman from instead of 10,000 people, which narrows it down like that. And in addition to having these attributes manually labeled, there are algorithms available which are related to face recognition in the same pipeline, which are expression recognition, gender recognition, even ethnicity recognition, which narrows down the search a little bit. Now, playing it again. From smiling, I clicked on one of the images here. These are just half the images are labeled because these are the labels available for this data set. They don't have labels for who this person is. Not in this one. There is another data set called CelebA-HQ, HD data set, high definition, where if my memory is serving me well, then they do have the names of the celebrities as their folder names, but this is what we have now. So now I picked this person to see what other attributes they have. It came up with big nose, mouth slightly open, the accent rise, that was a little insulting, I guess. No beard, young, has brown hair, high cheekbones. And if we keep playing around and go ahead and click on one of the attributes, mouth slightly open. Now from there, we went to picking other celebrities where in the pictures the mouth is slightly open. And the beauty is, if you can see, this is connected to some of the celebrities who are also smiling. So say you need to find a celebrity picture or just any picture in your data set. Maybe this is not even a celebrity data set where you want to find a person you know is wearing glasses, you know has bangs, and you know who is a male. I'm just thinking about how easy it was to um, get to that person using the graph database. And from there, there was one very interesting thing I noticed here, which might not have been possible if I'm just looking at 40 columns in 200,000 row table or a CSV file, is that this person has wavy hair and straight hair. Now, I will be honest, I did not go back to check what is going on here, but it's simply not possible to look at this in a flat table unless you run a query. But how do you even know to run a query? How many attributes can you check like that? So this is just that importance of or the significance of using graph databases, and you can just play around with it however way you want. Sky's the limit. I'm going to conclude my talk with a few key takeaways, which is I went from thinking in rows to thinking in relationships. while using SQL and pandas in Python, I was thinking in terms of tables, joins, and keys. Whereas now I think in terms of connections. How do entities interact, not just what they are? I went from features to context. Before, image attributes were 40 independent columns, whereas now there are interacting traits in a network. For example, from the CelebA dataset, I was able to see how smiling connects to young. There could be other interactions, like maybe older people are happier, maybe younger people are happier, um, maybe people belonging to a certain demographic group wear hats more. So there are other interesting traits that that became very obvious when I started using graph databases. I went from computation to exploration, from joins and filters and asking myself what to join, to understanding what is connected and what is the shortest path to get from point A to point B. And finally, data points to systems, which is each data set was a separate file, like each sub data set was a separate file. But now I see it as part of a living ecosystem. From the anomaly detection example, there were several tables which are associated with the same project, but there were different data sets, and I had tens of tables that I had to work together with. Graphs helped me move this into a big living system, and they help me think in systems and not just a snapshot. Okay. And finally, I have mentioned that I have used Neo4j desktop to be able to do all of this, but if you don't want to use if you don't want to download another web application or another app onto your computer, these are the other options. You can use Neo4j or cloud, which is fully managed, and a free tier is available as well to be able to build basic things. And you can also use Neo4j browser. You can also use Cypher directly in Python via Neo4j driver. This is the one I did not test at all, but this is called Neo4j Bloom, which is a no-code visualization tool. And that's me. You can find me here. You can reach out via email. That's my LinkedIn. And if you're interested in finding out what cool things Attention Arc is doing in terms of media and in terms of data, please feel free to follow us. Let's follow the company on LinkedIn as well.
Super cool. Thank you very much, Suha. That was very interesting. Very great talk. Thank you for that. Let's see. I don't see questions in chat yet, but if you have any, don't be shy. Put them in. I have one, or one or two. So when you I think you hinted at this a little bit, but maybe you can elaborate a little bit. When you modeled the face recognition data set, or when you're working with face recognition in the past, and then now all of a sudden with this revelation or with this new approach here with graph, what was the most surprising thing for you that you then all of a sudden was possible or was opening up to you, where said, hey, actually that's new, that's different approach, that's very interesting to look at from this angle that now with a graph database has been made available?
I would say the biggest thing was still I'm not going to play the video again, but what I said about relationships. Before, all these were 40 independent columns, and we are talking about 10,000 identities from this openly available data set. But I was working with cross-spectral face recognition, which has even more attributes.
Yeah.
Which has within thermal, we could use different color palettes for different experiments. There is just a lot going on there in terms of attributes. It's just I don't have access to that data, but I can imagine how great it is to see those connections, not in just flat tables, but in terms of graph databases where these connections are just, oh, I went from smiling and I clicked on these couple nodes, and at the end, the smiling person has curly hair, has a mustache, and wears glasses. So how narrow this problem becomes in terms of finding a solution and getting there.
Yeah. Cool. And then maybe one more question. Since you outlined your journey a little bit coming from the SQL, and then you realized, oh, actually, this is a little bit cumbersome. I need to write 20, 30 lines of SQL to get somewhere. I need spaghetti tables that are all over the place. And then you dove in to learn graph databases, to learn Cypher and GQL, and you outlined this with Graph Academy. Is this, is this the first step you would recommend everybody else to take if they were saying now, okay, I'm a data scientist, I want to I realize maybe I'm struggling a little bit with my current setup. Is how do they get started with graphs? How would you recommend a beginner to start this journey that you completed already?
If they are in my shoes where they know a little bit of Python and SQL, especially SQL, I would say Graph Academy, just spending half a day, if you have available, to just click over some things. I mentioned the graph fundamentals and Neo4j fundamentals as an example, but there could be some other tutorial that is more tailored to your projects you're working on, your interests. Could be passion projects, could be work-related projects. I would say that is a great place to start.
Cool. Yeah. And then maybe final question. When would you say this whole graph thing clicked for you? When was your moment to say, okay, now I see it, now it makes a difference, now this is huge, and this is worth your time and worth looking into more and elaborating the analysis with a graph database?
I probably have more than one answer for that. But just to tell you a little bit about how I think about problem solving, is I just jump into it. I don't think about the end result, because whatever you're learning is never a waste of time, is never a waste of energy, because you are learning something from it. So I just, after I met Ari and Allison at this conference who work for Neo4j, I started talking to people a little bit about graph databases. And when I started working on that anomaly detection project for work, just based on how many tables there are, I was like, okay, I need to find something which could make my life a little bit easier.
Yeah.
And I have an intern who I need to explain these things to and ask him to do things as well. So if I don't understand this data well,
Yeah.
help him understand this. So from the experience from that, and at the same time, the biggest motivator was getting accepted to speak at Notes last year.
Okay.
I need to learn this now. If I could present something. So that's when I started jumping in and trying to learn something about this. And the time it became, to me, it felt like this is very useful and this was the right step. Was when the recorded in the video I showed with me just playing around, clicking on different notes and relationships. That's when it became very evident that this is going to be very useful for many data science projects I'm going to work on in the future.
Cool. Okay. That's great. Thank you very much, Suha, for presenting and for answering the question. Thank you, obviously, for taking the time to come at it one more time, for everybody to actually enjoy what you're talking about. And sorry again for the technical issues we had with the other day at Notes.
Thank you so much for the opportunity.
Yeah. Thank you. At any time. And it's great to see you, right? I mean, this is a great journey as well for everybody out there. You talked to somebody at Neo4j at a conference, you were interested, you tried it out yourself, and then a couple of months later, you are actually on stage at Notes to discover, to share and to talk about your journey and talk about what you did and how it helped you. So you can see that it's sometimes a very, very quick turnaround. And if you have something interesting to share, you build something with Graph, let me know. I'm always looking for guests for these sessions, but we're also looking for guests for Notes. So there will be another Notes in the autumn this year. Before that, we have a couple of other things. Next week, it's already March, so Jesus and I will be back for another Going Meta episode the 3rd March, so next Tuesday, basically in a week from now. Also next week, Road to Nodes kicks off on the 5th, so that's the Thursday. We will be having very, very interesting sessions this time on AI with graphs, something very basic. We start with fundamentals on Thursday with Martin, but then we go on Microsoft Agent Context Provider. We dive into GraphRec with GNNs for healthcare, graph neural networks. We do some MCP server, of course, and we do some memory and context graph. So we'll cover all the hot topics, I would say. So don't miss it. Join us starting on next Thursday, and that all leads into Nodes AI that's happening on the 15th of April. So the call for paper for that one is closed. So unfortunately, you won't be able to make a submission for that one, but we will be sharing Nodes 2026 dates soon. But we will have very interesting conversations and sessions from experts, graph experts and AI experts globally at Nodes AI on the 15th of April. So that's the next big one. And yeah, if you're wondering what next, Suha already mentioned the Graph Academy, Neo4j Aura free. It's great places for you to try and to play with Neo4j and have a go at it, all free. And if you want to know what's going on with the community, if you have a question, or if you want to read on about a couple of tutorials and some hands-on guides, then check out our developer pages. They have just been refreshed with new content and an updated look and feel. So I think it's a great place to look at these things. And yeah, with that, thank you everybody for watching today. Thank you again, Suha, for your time and for the great presentation. And I hope to see you next week at another live stream or somewhere around the globe at another conference or meetup. Happy to engage and talk to you.